Hello and welcome to Math Foundations 20, Section 3.4, solving problems involving acute triangles. Learn about the math problem here. So this one's kind of fun. We've got two security cameras in a museum, and they want to monitor a new display of fossils. The cameras are mounted 6 meters above the floor and directly across from each other on opposite walls. The walls are 12 meters apart, and the fossils are displayed in cases made of wood and glass. The top of the display is 1.6 meters above the floor. The distance from the camera on the left to the center of the top of the display is 4.8 meters. Both cameras must aim at the center of the top of the display. What is the angle of depression for each camera? Okay, wow, that's a lot of information. So, what we want to do here is we want to draw a picture of all this information. So we need to draw this room. So this room here is 12 meters wide, it tells us. Right, so the walls are 12 meters apart. Right, so that part there is 12 meters. We've got the display is 1.5 meters tall. So I guess we could set the display in here. So that's 1.5 meters tall. We've got the, what else do we have? The walls are, or the cameras are mounted 6 meters above the floor. Right, so those are kind of like our walls. So 6 meters, 6 meters. Okay, so the cameras are going up on each corner here. And those are 6 meters. Right, and what else do we have? And we have the distance from the camera on the left to the center of the top of the display is 4.8 meters. So the distance from here to there, right, is 4.8 meters. Okay, so what else we have then is if we were to close in this top, right, that would be 12 meters wide. And since the walls are 6 meters tall, that means from here down to here should be 4.5, because this display part here, right, is 1.5 meters. Okay, so that's what we have. And essentially, right, what we're looking for is, right, that part there, want to know that, and this part here, we want to know that. Right, so the angles we're looking for is like theta there, and say alpha here. The angle of depression means from a horizontal like this, down, how far down does it go? Okay, so we want to find those two angles there. So we have, right, an acute triangle, perhaps an acute triangle, and we have that one side is 4.8 meters long, and another side is 12 meters long. Right, so that should be enough information to give us something. Well, so we've got, right, that this here, okay, so this here, theta, across from it is this side here, which we don't know. Alpha, across from it, right, is that side, which we do know. And this angle here, across from it, right, is that side there, which we do know, but we don't know the angle. Okay, so where does that leave us? Well, if we look at that 4.5 meter part, this part here actually forms a right triangle. Right, so we've got a right triangle there that we could use to solve for theta. So we could go theta, and we have the opposite and hypotenuse, so we could go sine theta equals opposite over hypotenuse. Okay, and then solving for theta, so it's going to be second function sine of 4.5 divided by 4.8, and we get that angle to be 70 degrees. Right, so the angle up in this corner now is 70 degrees. Okay, so we have that is 70 degrees, so we're kind of halfway there. So what else do we have now? So we have that that's 70, and what can we do now? Well, what about this side here? Right? Do we know that side there? No, we don't know it. Can we find it? Well, one approach, yeah, is we could find that. So now we have the 70 degrees, right, matches up with that. We have this other side here. We have this other side here. So basically, we've got, right, side, angle, side, and we're looking for the other side. So that is a cosine law situation, right? So we could use cosine law there to look for that side across from it. So that's, right, just cosine law. We've got x squared equals 4.8 squared plus 12 squared minus 2 times 4.8, running out of space, down to the next line, times 12 times by cos of that angle there, which is 70. So if we calculate there for x, couple steps, x is going to be 11.3 meters. Okay, so we get that to be 11.3 meters. Now, kind of what do we have? Well, we've got all three sides of that big triangle. We've got one of the angles in that big triangle. Right, so we could use cosine law in the big triangle. Right, if I just kind of resketch that big triangle, something like that. We've got 11.3, we've got 12, we've got 4.8. Right, so we should be able to use cosine law there to find alpha over here. Right, so doing that, that's going to be, right, which side is across from alpha? Well, that's the 4.8, so it's 4.8 squared equals, I'm going to change colors actually. Right, 4.8 squared equals 12 squared plus 11.3 squared. Take away 2 times 12 times 11.3 times by cos alpha. Right, and so then we're going to have to isolate for alpha. Right, so those are skills that hopefully we practiced quite a bit in the previous section. So to get alpha by itself, right, we're going to have to subtract this over, and then divide by all of that, and then second function cos. And so doing that, if we round to the nearest degree, we end up with alpha is 24 degrees. Okay, so there is 24 degrees. So those are our two angles of depression. All right, so these problems are pretty tough, right? We started off, we really had no idea where to go, and it's just, okay, do we need to break it into a right triangle? That's what we did here, right? First we broke that triangle off and just worked with it. Then we worked with the entire triangle. In the end, we could have actually broke off this triangle here, right? And that would have been a right triangle. We could have worked with just that, right? There's different ways of doing it. You got to try things. You have to be confident. You have to be comfortable. Right? If you look at it and you just get stuck, right? It's really hard to do, but you just have to kind of just try things. Do what you can. Do your best. All right. Thank you for watching. Good luck.